Hey guys, I'd like to tell you today a little bit about functional UI. Some of you probably know it's a joke because the real talk is about JavaScript. So let me introduce myself. I'm Mike and I work at a company called Man and Moon. We kind of like write multi-platform real-time apps in JavaScript. My Twitter, GitHub handle is in the bottom right corner, and if there is like any native speakers in the audience that could kind of like help me with spelling this properly, I'd appreciate, because yeah. So I work with Daniel, who was here on stage yesterday on that project called Eshte. It's a dev stack for developing React.js apps. Thank you, thank you. Yeah, so it's like we recently added Redux and universal data structures. Basically, as you can see from the slide, maybe, we have just fixed the internal error, which is cool. So, basically, I think users quite like it because of the number of stars, obviously, and I mean, it's probably a fake, but it still looks cool. So, okay, today we're gonna basically talk about JavaScript and only JavaScript, because, the problem with DevStack today is that they are highly opinionated, meaning that you have to somehow agree with the authors on a certain set of features and patterns in order to take full advantage of what they have to offer. So our goal today is to kind of get us to reflect how do we work with JavaScript and how do we develop React.js applications so that we can target multiple platforms with minimum effort. And before we kind of move on, that's Adi Osmani, by the way, and in one of his books called JavaScript Patterns, that I strongly recommend reading if you haven't yet, he said, patterns are not supposed to just capture principles or strategies, they need to capture solutions. And I think that's super important nowadays because we tend to write a lot of abstractions for sometimes just for the sake of writing, so we should kind of like nail down all the cases we have to handle before we will carry on to the next slides. So let's kind of like step back and think how we used to write like mobile and web applications a couple of years ago before React and React Native. We've been kind of like always building these applications separately in independent code bases so that we've been always kind of like writing Java for Android, Objective-C, or Swift for iOS, and obviously JS for web. And what we have noticed is that there's a lot of problems that we are dealing with. We've been kind of like solving twice, like fetching data, validation, all these kind of like crucial to our application look and feel features we've been solving multiple times on different platforms. And if you take a look what features are kind of like duplicated, there's kind of quite a lot of things and that's shared. Things like fetching data, syncing user actions, caching data locally, all these things like we've been building multiple times, and it's sometimes hard to get them right properly once, never mind getting them right twice or 3 times. So we kind of like have not only a bigger application to maintain and develop, but also the costs, of the entire development are twice or triple what they should and could be actually. And what you ideally want is the kind of like guarantee that the application behaves consistently on different devices, providing the same user experience. And because we have the same set of, because we have like different teams of engineers when working on this application, when they come to some like edge cases or some problems, they may have implement them differently, which will cause some inconsistencies between these platforms. And then React Native came in and changed the world basically by integrating iOS and Android into the same code. So now we are now kind of able to share interfaces, logic, all that stuff between iOS and Android, which is cool. And that's the approach we also took in Eshte for a couple of months, because if you were following our development, we used to have Eshte Web and Eshte Native, 2 separate projects, and we just basically copied and pasted all the stuff to a new project. And if there is like a bug in React code, everything is super simple because it's JavaScript, and all you have to do is kind of answer a couple of questions, like who owns the code basically, because you don't know who created the code, who's the author, whether you should kind of like fix it locally or push it to another repository. Does it break on other platforms? We are not sure because you own only a specific part of the app. Was it already fixed somewhere, or is it a regression? And these questions just add up as you keep product development, and by the end of the day, all you want to say is what? So, all right, so we kind of like seen already 2 different takes on product development. And what we are going to do now is we're going to explore the third one, which I personally like calling stack of tomorrow. But to be fair, it's not really a stack of tomorrow. It's actually a stack of today because, the principles and the core patterns, turns out they were already implemented by other companies like Facebook, Dropbox, Google a couple of years ago. It's just thanks to the proper tooling now. This is kind of like easy for us now to do because there is JS, there is React and React Native. We don't have to handle like low-level C code between these platforms because, JS is just easier to maintain in this specific case. And we've been successfully able to integrate it into Ashta a couple of months ago, and it's already available live for you to try out. I mean, we are still nailing out edge cases and kind of like rewriting all the stuff, but we think it's kind of like stable enough, so we did update the README, so I can recommend you trying this out. So what are the problems we're gonna solve today? Well, the first one is the code duplication, as we have already seen. It doesn't matter whether you're writing like this code again, from scratch reinventing the wheel, or just kind of like copying and pasting these things. It just doesn't matter. It's something you will fail shortly at when these inconsistencies are introduced. The second one is lack of portability, because by having duplicated code and logic, you increase the effort of maintaining all these things. And if there will be like an idea to target another platform like desktop, it will be super hard for you because there is no clear way of writing these things. They are also hard to maintain. We've seen these questions like who owns the code, where to push our tweaks. This is quite tricky to do on a daily basis. And the last thing is unresponsive development. Because, we need to make sure the quality is met in a separate projects. We need to, communicate the same ideas multiple times. It just doesn't work. Because, developing application for multiple platforms should be something fun and should be something you are excited about, not just pissed off with the edge cases, So that's why you have to have like a really good way of doing these things. And we're gonna see how we can approach this problem. So what are we gonna do about the code duplication? We've been thinking with Daniel in Ashta for a couple of weeks how we can solve this problem. And it turns out it's been already solved. It's been already solved with C++ libraries shared between iOS, Android, or desktop clients. That's something what, for example, Microsoft was doing on Dropbox. So kind of like, why not just apply these things again to our use case? As you remember, that's the two code bases stuff we've been discussing in the previous section. And what we can do with it? Well, we can start treating our applications like iOS, Android, web, and desktop as first-class citizens and just revamp the code structure to a single code base. And you're probably thinking that, this doesn't solve the problem but complicates things because, there's going to be a single code base, a lot of, edge cases and things to handle. But with a proper tooling and proper organization, this is quite easy to do. So starting from now on, our application logic is going to live in a single place. And we're going to call it core. And there are these two things called platforms, React Native and React. And the platform is like an independent platform-specific code located in our project. They do not interact with each other. They just reuse the application logic we have done. And not even all of them, because it's up to them what set of tools, package managers, and kind of like reducers they're going to use and what's going to work best in their case. So just to follow the slides, they can have platform-specific logic, custom components, web-only DevTools, for example, or some other APIs and stuff. And speaking structure-wise, this is how it can look like in real life. There's like a package JSON and a couple of high-level settings, like for ESLint or Bubble. There is the place where the core lives, like utils and some UI. There's also that folder platforms with web and mobile, where your target's gonna have their code. And you may be probably wondering, what are we gonna use for the data layer? And we've been kind of like trying to figure out the best way to do this. It's not going to be anything functionally reactive at this time yet, but we are going to go with Redux. And this is the quote from yesterday, by the way, from Twitter, which is quite cool. And somebody created a really, really cool starter project, which is called SoundCloud, and it's written in React Native. And he said, like, having Redux as a data layer, it takes no effort to switch the view layer from DOM to React Native. And it's actually quite true, because if you will take a look how we done this in our project, it's actually pretty simple. All you have to do is you have to import the core, configure core store function from your core, and just kind of like call it when you are configuring your platform store. And you are probably like, why do we call a function in this case? well, what if I told you it can accept some sorts of arguments? Like in this case, as you can see, you can pass it a platform-specific reducer or some dependencies. We'll see why in the next slide. Middlewares, pretty straightforward. I mean, this kind of code is pretty likely probably to change, and it's highly kind of like opinionated. So if there are some other people that prefer more functional approaches or other stuff, they can kind of like figure this out. So as per the platform-specific APIs, this is a simple action creator from Redux, which is called login, and it returns a function. We are using in ESTA a middleware called inject dependencies that Daniel was talking about yesterday. And basically what it does, it allows you to inject some services without requiring them. So we can write your actions in a cross-platform manner, and then you can kind of define what fetch is gonna be in web, and for example in React Native. Obviously in this example, this doesn't matter that much because React Native does have fetch, but for example segment.io for web is okay, but for React Native it's quite cool to use the native library because it batches requests and generally optimizes the battery life. And the second thing is lack of portability. You know, in a smaller team like my own, it usually all starts with a single platform first approach like Android first or something like that. And then we add in more targets as we grow or release MVP. And you know, this is important to keep in mind that the way we write our software should be future-proof and allow adding new platforms with minimum effort. So let's check it out and see how we can do this in this universal code base. So here's the diagram we've seen. As you can see, there is the application core and these platforms. So say we want to create a desktop app because we have just discovered Electron or React Native for tvOS is finally in stable version. On a side note, there were a couple of questions how the React Native tvOS development is going. I have to say we are almost there, but if you will have any questions, just kind of ask me later. So it's kind of done. I mean, since all these platforms are kind of like independent from each other, adding one is just a matter of kind of this. You just clone, install, and start your project. So the consensus is that it takes just seconds to add in a new target, or an hour if you are using npm-free, but so it turns out like there was somebody who said like your project is just a collection of standalone UI applications and nothing more. And I have to agree with this a lot, probably because it was me who said that, but so okay, 25 minutes, let's say, for the talk is not enough actually to describe all these things because talking about code can take like days and weeks. And I was thinking for a couple of days what should be the next topic we are gonna talk about. And I have discovered that really cool article on Medium by Sarah Cooper titled 10 Tricks to Appear Smart During Meetings. And guess what was the top highlight? Well, this scale. So that's gonna be another thing we're gonna discover. That's actually a pretty good question because a single code base, lots of platforms, lots of dependencies. This is something that can get messed pretty quickly. And this stuff is actually highly opinionated because it's kind of like our specific use case. So if you will find like some of these things are not applicable to you, you can kind of like check out ESTA because up to this point, all these things are in ESTA. The rest of these things is gonna to be in the project I'm gonna share with you after the end of this talk. So there seem to be like two big issues with single code base actually, at least in our use case. The first one is dependency mess because like 2, 3, or 4 platforms in one repo. It's like some people don't even get that. And the continuous integration because tests need to be fast, yet they need to cover all our platforms. And the first approach that can work for you would be to have all dependencies in a single package JSON. And this is good for like small apps or applications that demonstrate use cases like to-dos MVC. And this is the approach that we have in ESTA. But there are cases where it doesn't make sense. Like when you have 5 platforms, you are growing, you say you are planning to support other platforms. There is no like reason to ship, for example, React Router and React Native side menu actually. So let's take them, and I don't know if anyone knows what's the result of this operation. if anyone could tell me, because I can't. So I was going to ask you, because these are the sort of the confusion you're gonna get when you kind of like mix all these things up and you are like, what? So dependency means, the key problems we have here are too much is shipped, which is pretty like obvious. I mean, it's quite crucial to optimize our build times and deployment times, especially as our code bases grow. And if Dropbox or Google having a single code base were deploying everything everywhere, it would have been an overkill. It's super hard actually to reason about because imagine upgrading dependencies. You can't tell what things has changed because you don't know what platforms are using what. And this is kind of like something I was accidentally discovered this yesterday with a couple of friends while having a beer, because they were like telling me that the NPM ecosystem is super hard to work with because you have so many dependencies and they change a lot. And he was like, yeah, we've upgraded like 25 dependencies because we were not doing this for half a year. And he was like, we had like maybe 50 use cases or something like that, and they still were unable to cover all the edge cases because of some things. Because you usually think like, okay, that's the dependency, it surely works, so I'm gonna keep focusing on my logic. So you can't be sure that some upgrades won't break your app. So as I said, these are the tricky upgrades plan actually, and we have bad developer experience because when we are kind of installing the code, we have like 5 teams, for example, and let's say my team is going to work on web because we have like, okay, my team is going to work on iOS because we have Macs, for instance, but another team is going to work on web because they have Windows. And if we require to install all the platforms, they will fail because, mobile, for example, downloads some iOS dependencies, which obviously doesn't work because of Cocoa pods. So what we can do is, as we have said, our platforms are first-class citizens. So what we can do is we can use the best things they are equipped with and declare their dependencies in a clear declarative way. So how we can do this? Well, we can use NPM on both platforms for JS sort of stuff. We can use Cocoa pods on mobile, obviously, for native dependencies. And, for example, Webpack on web to handle some build processing and stuff. And, speaking structure-wise, these are just another files in your platforms, so you can easily integrate that. This is kind of like clean and super explicit. If you're ever gonna have a require from your platform, you are sure where to look for it. The trade-off is that in some cases, you may end up having the same dependency in all these free packages like mobile, web, and core, let's say Redux, for example. And this is true, actually. But since they can coexist, like, I think it's worth doing this given the maintainability and other gains you get because of this structure. So that's solved. Now it's time for the continuous integration. By the way, how many of you guys kind of like use some sort of continuous integration tools? Oh, pretty cool. Keep it up. So we are probably kind of aware of how does the typical commit lifecycle looks like, but just check it out. So first thing we do is, after we commit our changes, we run tests. And in real life, like if you have a couple of platforms, it may take like a couple of minutes, 15 minutes, for example. And if they fail, well, they have to run again, and you just wasted like 15 minutes. So okay, after all things pass, there is the build process, and after all, if all succeeds, we are shipping the stuff. So we have just wasted 15 minutes. Probably not an issue because we usually check out Facebook or Twitter, so that's a good thing. But let's think, why did this happen actually? Because it turns out, because of the fact that we have all the platforms in a single code base, we have to run the unit tests and integration tests of all of them at the same time, which is sometimes pointless because if you change web or if you change mobile, what's the point of running tests in web? And it turns out this is again not a new thing. This is actually something that people were doing for a couple of years. There is, for example, a quote from somebody from Facebook, from the FA conference, and they said, "We want our developers to get feedback as quickly as possible by running minimum amount of tests required." And I think we have to agree with this because, waiting for tests to pass is a bad thing. Writing tests should be fun because you are kind of like sure about the platform, about the behavior of your code. And if you are going, your developers wait for like half an hour for the test to pass, trying to get them to work in test-driven development manner is going to be hardly doable. So what we are ideally looking for is the way to trigger our platform tests based on the changes we were done. So say, for example, if, I don't know, if we change web, we only run tests in web. If we change mobile, we test mobile. But if we change core, we test all of them. And you know, since they are completely independent from each other, this is quite easy to do. This is actually a code snippet that we have in our project. These are like helper scripts you can use to run some tasks. They are written in shell.js, so I hope they work on Windows as well. And there is that test diff script that basically runs something we'll see next. And this is how it looks like. Basically, we get diff from the GitHub hash, from the commit hash. We extract folder names from it, we deduplicate this, and as a result, we get an array of, for example, core, web, or desktop, so we know what to run. And then we just kind of like iterate over these folders, and we run command in path. So it's quite flexible. You can write your own kind of helpers on top of that. You can use npm test or whatever you want. Well, so, you know, like, can we do better than that? Because, you know, there are still a lot of things we need to kind of work out, like you know, these dependencies, like separate packages are quite weird. Ideally, what we would like to is the way to structure all the things in a good way. Well, the first thing, the biggest one is probably React Native doesn't ship with React. Because, you know, if you are like following React Native development, you probably are aware that, you know, React Native uses vendored copy, which is currently 0.13. And if you want to use 0.14, you can't because, you know, there are two different versions in your code base. So if React Native starts depending on React, from NPM we can now not only optimize the way we reuse components, but we can also, for example, change the way we declare pure dependencies for some React Native components so they work in a better way, as well as the some cross-platform web versions. They're gonna work as well. Another one is that Webpack works with React Native. You know, if you will take a look at the first 10 issues, I guess, from the React Native repo, you will see there was a long talk about why to use React Packager over Webpack. And you know, people from Facebook were like, we wanted the process to be fast and kind of optimized for the, you know, mobile development. But it turns out there are a couple of features of Webpack you'd like to still have. And you know, there is that project called React Native Webpack Server, I guess. Unfortunately, it has a couple of issues, so if you're gonna use it, sometimes you will have problems with upgrading. But generally, I would like more work to be put in this project because, you know, then you can reuse your kind of configuration between web and mobile. And for example, like React Packager and Watchman basically don't support symlinks, so npm link doesn't work and other things. So it would be actually quite cool to use like Webpack resolve alias and, you know, problem solved if you don't like relative requires. Next thing is cross-platform styles. This is quite huge actually, because when we were developing applications for web and mobile, we didn't have that many, you know, problems with reusing components, because it turns out like, okay, iOS and Android are quite similar. But if you will take a look at the web, it's completely different. What you can reuse are like styles, some constants like colors, or maybe like small components like to-do input, something like that. So generally, it would be quite cool to share these styles. There is that project called React Native Web that tends to kind of like have cross-platform style sheets and other components from React Native that work as actually in web, which is quite cool. Because, you know, the problem currently is, if you will take a look at any inline styles library out there, like Radium, for example, they all are similar, but they have still different syntax than style sheets from React Native, because React Native style sheets are camel-cased, and some of the styles are not supported. And you know, if you pass too much to your components, you're gonna end up with a red screen of death. So that's something that could be improved in order to write our apps in a better way. And you know, as the last thing, you implement that in production and give us the feedback, and we can kind of keep the JS world up and going. So these are the links. You can kind of save them or visit if you want to check it out, I'll also like try to post them somewhere, maybe on Twitter. The first one is the one I was specifically talking about regarding the way we test apps and the way we develop apps. The second one is Eshte. This is the project we work on full-time with Daniel. It's like a web dev stack that has native as well. And that's something we put all the things that work for us in production, and then we kind of see how it works for the community. So thank you very much for listening to me in the morning.
Great. We have time for 2, 3 questions.
Yeah. Oh, yeah. Yeah. Where is the one about jQuery with Eshte? Are there some production-used examples built with Eshte which we can overview to get an idea how it looks, work, feels? Well, I can't speak for Daniel, but if you ask me, we are actually launching a product called Push for Champagne, which is a product you can like click and order champagnes. We are launching in London next week, and we are waiting for Apple review. I left a couple of backdoors in the app, so if you'd like to check it out with me, just kind of like drop me a line. So in 2 weeks, there's gonna be a fully universal app with web, desktop, mobile, and Android version. So you can kind of like, then I can show you the links and we can see it out. Can I write my own platform port, like for tvOS for Eshte? Yeah, of course. I mean, as long as tvOS works in a good way that you can kind of get it from the NPM, then it shouldn't be a problem because, you know, as I said, it's all about having these folders in your platform or source, so we can create a new folder called tvOS and kind of just do what you want to do. Is Eshte production ready? Well, yeah, I think so. I mean, we are building some production apps with it, so it should be working fine.
Cool.
Well, maybe last one.
Yeah, one more.
Does Eshte Universal run on Windows, or do I need Mac? No, it does run on Windows. It might be just a case of, you know, the scripts, because it's quite hard to get right 3 or 4 command lines on Windows. So if you would like to help us with that, then sure. But apart from that, it's just, you know, JS, so you should be fine.
Cool, great. Thank you, Mike. Thanks.